also deploy a mobility controller as a standalone controller without any mobility master or anything, then yes, in that case you can take the CLI access, you can make changes, you can take the GUI access, and you can make the changes as well, right? For your virtual platform as well, you can make the changes independently. However, if these controllers are being managed by your mobility master, you need to understand that whatever changes that needs to be done on these controllers will be done from your mobility master. Now next is your architecture. So on your left side you see the architecture. This is how it looks like, right? First is your mobility master, right? Like I told you, it is a focal point in your Aruba A.X architecture, where from a centralized location where you're configuring, monitoring, troubleshooting, gaining the visibility of the entire infrastructure, and also adding in licenses, right? Now from itself, it will be establishing secure IPsec channels from itself towards the mobility controller to manage these controllers in a secure fashion, right? Now next is your access points. Now you've got different types of access points. You've got your map, you've got your mesh, you've got your spectrum analyzer, you've got your air monitor, right? You've got all these different types of access. And please remember, these access points terminate on your controller. They do not terminate on your mobility master, right? They terminate on the controllers. They do not terminate on the mobility master. Why? Because Aruba wanted to have a clear separation of their management plane and the control plane and data plane. The thing is, because the control plane and data plane, the thing with this, the advantage that you get with this is, if your access point, your mobility master being a very important component in your Aruba A.X architecture, right? It is a centralized location where you're going to configure, monitor, troubleshoot, and you're going to do everything from a centralized location. It is a very important component. Agree? But because of separating this management plane and control plane, the advantage that you get is, even due to that, in a very unfortunate scenario, if your mobility master goes down, it will have no impact on the production network traffic, right? Because all the access points are terminated on the controller, even the users. All the users, they will be terminated on the controllers itself, right? None of these will be terminated on your mobility master. Mobility master being a very important component, right? It is where you're going to configure, it is where you're going to troubleshoot, it is where you're going to enable the features, it is where you're going to add the licenses, it is where you're going to gain the visibility of your features and infrastructure and everything. But still, even if being so important component, Aruba, by separating the management plane and control plane and data plane, the advantage that we got is, even if it goes down, right? Obviously, we need to bring it up, no doubt about it. But even if it goes down, it will have no impact on our production network traffic, right? It will not have effect on our running traffic, right? Because all the access points are terminated on controllers, all the users are terminated on our controllers. That is the advantage that you get by separating your management plane and control plane and data plane from your MM to MC, right? Now next is your headquarters, where again typically, let us assume this is your DMZ location, where in your DMZ location you need to deploy one of your mobility controller as a VPN concentrator. What is this now? What is this VPN concentrator? Typically, you've got your remote access solutions, right? Out of which one is your remote branch office mobility controller, right? You've got your remote access point, right? You've got your IAP clusters, right? Like I told you. So I told you, IAPs do not need to have a mobility controller for them to operate. However, you can set up a IPsec tunnel from your virtual controller with this mobility controller and send all the traffic from that IAP to this guy, and it will send all the traffic to your airwave. Your airwave will be able to manage these IAP clusters, But if you want to manage your IAP clusters from your data center location using your airwave, yes, you can do that as well. Right? Now, that is the reason IAP also is a potential remote access solution. Remote access point is a remote access solution. Remote branch office mobility controller, yes, it is also a remote access solution. You also have VIA clients. What is this VIA? VIA is a VPN client software created by Aruba, which we can install on our mobile phones, our laptops to connect to our production network. Right? So all these remote access solutions, they will be first setting up the IPsec tunnel with this guy. Understand? Right? They will be all be setting up this IPsec tunnels. Right? These guys will be setting up their IPsec tunnels, and these IPsec tunnels will be setting up with this mobility controller deployed as a VPN concentrator. The objective of the VPN concentrator is it is the point of contact for all the remote access solutions to set up their IPsec tunnels. From here, this mobility controller will be forwarding the traffic to its proper owners, right? To the proper owners. You want to manage your VIA from your mobility master, that traffic will be sent to your MM. You want to terminate this remote access point on this controller, right? That traffic will be forwarded to that mobility controller. You want to manage your IAPs on your airwave, right? That traffic will be forwarded to its correct one. However, there will be one single point of contact that will be VPN concentrator for all your remote access solutions. Right? Now, next is your comparison between your 8.x architecture and your 6.x architecture. Like I told you, in your 8.x architecture, you have got these two components. One is your MM, one is your MC. In your 6.x architecture, you have two components in that as well. One is your master controller and other is your local controller. Now we are comparing MM, our mobility master, with the master controller. Right? Now this mobility master comes as the physical appliance. Yes, you can deploy it on an x86 based hardware appliance on a bare metal server, or you can also deploy it on a virtual machine as well. When you talk about your master controller, it only came as a physical appliance. You were not able to deploy that on your virtual machine. When you talk about your APs, right, your APs, it's not about cannot, it's do not. APs do not terminate on your mobility master. Why? Because I told you the advantage that we get. Because Aruba wanted to have a clear separation of the management plane and control plane and data plane. Mobility master being very, important component of the Aruba 8.x architecture. Still, if it goes down, there must be no scenario that it actually affects the production. Because of that, APs do not terminate on your mobility master. However, in your 6.x architecture, APs did terminate on your master controller. Meaning that if the master goes down, all the access points that were connected to the master, even those goes down, and eventually that's going to affect your clients. Right? Now when you talk about your 8.x architecture, it can push full, the keyword full config to your local. Now what is this local? These are the terminologies used for your mobility control. Your mobility controllers can be called as MC, right? MC meaning a mobility controller. MD meaning managed device. Also MN meaning managed node. I do not get confused. It is just telling the same device which is your mobility controller, where it can push full configuration to the controller. Right? When I say push, when I say full, what I mean is it can push both wired and wireless. It is capable of pushing each and every configuration. If you want to push configuration with respect to wireless, or if you want to push configuration with respect to OSPF, BGP, static routing, VLANs, IP address, as simple as changing the IP address of the controller, you can also do that from your mobility master, right? But when you talk about your master controller, it was capable of pushing only partial configuration, right? It can push only partial configuration, meaning that it is capable of pushing wireless configuration However, it is not capable of pushing a wired configuration. Meaning that whatever routing, switching, VLANs, whatever these kind of configurations that you need to do on your local controllers, you have to take explicit access of those devices, make those changes independently for them to be reflected in the production network. Right? However, in our a.x architecture, MMC architecture, MM is capable of doing everything, wireless, wired, everything with respect to your control. Right? It performs a complete configuration syntax validation before it pushes the configuration towards your mobility controller. However, in your 6.x architecture, the same is not. Here we are comparing the MC with the local controller. Right? The MC comes in both hardware and physical. Your local controller came only as a physical device. Your mobility controller receives the entire configuration, both wireless and wired configuration from your MM. Your local controller was only capable of receiving wireless configuration. For the wired configuration, it is not. Right? So this is a graphical explanation of what we discussed. Right? We talk about your 6.x architecture. Right? It's your 6.x architecture. Your your master controller is capable of only pushing wireless configuration. We talk about your wired configurations. You had to take explicit access of these devices, make those changes independently to be reflected into the production network, right? Which becomes a headache in a very large production network. You talk about your 8.x architecture, you don't have to worry about that because from your mobility master, both wireless and wired configuration, you will be pushing on your controllers in a same fashion. Right? Next is your Aruba A.x exclusive features. Right? When I say exclusive features, these features that we are going to discuss, this can only be used if you have got a mobility master. You cannot use it in a 6.x architecture, you cannot use it in your IFPs, you cannot use it in a master local setup, you cannot use it in a standalone setup. These features you can only use in your 8.x architecture, in that you need to have your MMC. Whenever I say 8.x architecture, this information should automatically trigger in your head. MMMC. MM. You need to have a mobility master. Right? So these are now, we are going to discuss the exclusive Aruba 8.x feature. Out of which one is your notable service module. What is the notable service module? These are different applications which runs on top of your mobility master. These applications are purposefully designed to help us with certain feature set. Right? AppRF is like a typical application. Right? So what does it do? AppRF is a control and visibility feature where it uses deep packet inspection on your traffic. Whatever client is sending the traffic, different clients sending the traffic, they're going to perform a deep packet inspection, and whatever application that they are using or they are working on, it will showcase you an intuitive dashboard on your mobility master. It will be able to detect around 1500 applications into your production. Right? So like that, all of these are different applications which we'll be discussing throughout this course, few of them, and other we'll be discussing in the advanced course, but yes, these applications are purposefully designed to help us with certain feature set, which runs on top of your mobility master, right? So your mobility master is built on your kernel Linux. Right? On top of that, you've got this Aruba operating system, which is your mobility master. And on top of that, you've got these different notable service modules, different applications which runs on top of that. Right? The beauty of notable service module is that each application comes with their own unique package that you can download from arubanetworks.com, upload it on your mobility master. You can upgrade them, you can downgrade them, you can do whatever that you want, right? Without a need of a mobility master reboot. You do not need to reboot your mobility master. Right? These applications, which is purposefully designed to help you with certain feature set, comes with their own unique packages, which runs on top of the mobility master. Right? So if you want to upgrade them, let us assume you are working on northbound API or WebCC. What is WebCC? WebCC stands for Web Content Classification, right? This is a layer 7 feature where if you want to control what enters and leaves your traffic, right? Typically with respect to the layer 7 traffic, you want to take certain decisions based on certain URL category or web category or app category, right? You want to allow or deny certain traffic in production network based on these categories. You will be able to do that with Web Content Classification, right? Now this is running, this is the loadable service module that is running on your mobility master, right? And there's a new version that has come after 2-3 quarters. You are interested to upgrade that, you can go ahead and do it independently. You don't need to upgrade or reboot your mobility master for the newer version of WebCC to be reflected in your production. And that's a good thing about the loadable service module. Now next is your clustering. Very, very, very important. Right? Clustering is very important. Now with clustering, you get these 3 benefits. First is your AP and client load balancing. We'll discuss all these points. These are very simple points, don't worry on that, but these 3 points are very important. AP and client load balancing, AP and client hitless, and third is seamless roaming. Right? These 3 are the critical advantages that you get with the cluster, right? Now, how does your clustering work? Right? Now, what is a clustering process? Clustering is a process in which your mobility controllers will be working together to provide you high availability and redundancy for your access points and your clients. Right? They are working together to provide you high availability and redundancy for both your access points and your clients. What is the process of clustering? So first, you as an administrator, first you'll be creating something called clustering profile. Right? You'll be creating clustering profile and you'll be pushing it towards your mobility controllers. Once your mobility controllers receives this clustering profile, first thing that is going to happen between your mobility controllers is they're going to first elect something called cluster leader. They're going to first select something called cluster leader. How is a cluster leader elected? First, a cluster leader is elected based on the priority. So by default, the priority value for all the mobility controllers is 128. If you have changed the priority value for a controller, then that controller becomes the cluster leader. Let us assume you did not change the priority value. It is by default 120. And the next what is taken into consideration is hardware model, or I can say superior hardware. Let us assume this is 7200 series and these are 7000 series. Then in that case, who becomes the cluster leader? A superior model becomes the cluster leader. Right? So in our case, it is 7200. Let us assume you had all 7200 series mobility. Then what happens? Third criteria that will be taken is here higher matrix, higher parameters will be used to elect a cluster. Right? So what is your cluster leader? Once a cluster leader is elected, what is the job of the cluster leader first? Out of many other jobs which we cannot discuss now, right? The first job of your cluster leader is to ensure it does the load balancing. Let us assume you've got 600 access points and you've got 6,000 users. The first job that your cluster leader is going to ensure that it evenly distributes the load of the access points and the clients evenly among the cluster. Along with that, all your mobility controllers will be setting up this IPsec, fully meshed IPsec tunnels with each other. What is the reason for this fully meshed IPsec tunnels with each other? The reason for that is synchronization. What are they synchronizing? We'll discuss that in a second. Right? But the first advantage we have achieved, AP and client load balancing. Right? There are certain algorithms that will be taken into consideration to trigger a load balancing, which we'll discuss that in the advanced courses. But for now, as an overview, this is what you need to know, that your cluster, with the cluster you get this advantage, right? AP and client load balancing, right? Next is your AP and client headless flow. The second most important thing is AP and client headless flow. How do you get this? Now, please remember that from your AP's perspective and from your client's perspective, there are two tunnels that get established. Whenever you have a cluster, automatically there are these two tunnels that are automatically that gets established. From your AP's perspective, one is active AP anchor controller, and other is standby AP anchor controller. Sorry, I cannot write all of that, I don't have space, but yes, this is what the tunnel is. From your AP's perspective, one is active AP anchor controller and other is standby AP anchor controller. From a user perspective, one is active user anchor controller and other is standby user anchor controller. Right? Now think, what is the advantage of these tunnels? Now look at this. You've got an access point. Now for this access point, whenever it is deployed in a setup where your mobility controllers are a part of the cluster, there will be two mobility controllers that will be elected for each and every component dynamically. You don't have to worry, you don't have to do that individually. All of that will be dynamically selected. One of the mobility controller will be elected as active and one of the mobility controller will be elected as a standby for your access. Now for this access point, one is the active, one is the standby, right? And like I told you, between this active and standby mobility controller, they have established this IPsec tunnel for the synchronization part. Now from your active, your active is going to be the controller which is going to be in charge of receiving all the traffic from this access point. All the tunnels that are established from this access point, all the tunnels will be established from that access point towards the active mobility controller, right? And this active mobility controller, this active AP anchor controller will synchronize each and every information about that access point towards a standby AP anchor controller. Now, what is the advantage of these tunnels now? Due to some unfortunate reason, if this controller goes down, do we need to worry? No, we do not need to worry, because the standby AP anchor controller has exact information, each and every updated information it has about that access point, right? And it will be able to take the traffic load from that access point without any delays. Even if this controller goes down, we have got a backup tunnel towards your standby controller which has every information about that access point, and it will be able to process the traffic for that access point without any delays. That is why it is called AP and client hitless flow. Now this is from your AP's perspective. What about from your user's perspective? From your user's perspective as well, there will be one mobility controller who will be elected as active, and there will be one mobility controller who will be elected as standby, right? So whatever information about this client, there is these three information, very important information that your mobility controller holds for your clients. What is that information? Firewall session information. Third is client state information. Third is authentication information. What is this firewall session? This guy is on YouTube, this guy is on Google, this guy is downloading certain movies, he's doing many things. He's on Microsoft Teams, he's doing he's accessing many applications, he's doing many things from that device. All that information, your mobility controller will be able to maintain that information about your client by storing a firewall session information. Next is your client state information, like what is the IP address of the user, what is the MAC address of the user, to which access point is connected, right? All that information will also be held by your mobility control. Authentication information, this user may have performed a .1x authentication, right? And that .1x authentication, when the radius server has authenticated this client, this client, let us assume this client Shoaib, right? And we have got a radius server, right? We've got a radius server where this radius server has authenticated this client Shoaib. Between this client and the radius server, there are certain keys that will be generated, right? This key information, the cache of the keys will be maintained by the mobility controller. Why? We'll discuss that when we're discussing about role, right? But for now, please understand that it is having this cache of this key, which was generated by the radius server and the client. That key information, the cache of those keys, also called as pairwise master key, that will be maintained by your mobility. Right? So this Shoaib is connected on the production network. He doesn't know that is happening in the back end, all of this is happening, he doesn't know, he doesn't care. But from our perspective, this is the active user actor controller, this is the standby user for sure. Now due to some unfortunate reason, if this controller goes down, do we need to worry? No, because the active controller, the active user anchor controller have synchronized each and everything about Shoaib with the standby mobility controller. Firewall session information, he's on YouTube, he's on Google, he's on Teams, he's watching movies, right? What is his IP address, what is the MAC address, and the cache of it. All of this will be shared by a standby user anchor. Now, if this also goes down for some reason, and the standby controller will be able to take the traffic without any delays. That is why it is called AP and client hitless. Now, third is your seamless roaming. What is the seamless roaming? Now, like I told you, your controller, right? Your controller for a particular client. For each and every client, there will be one which is active, one will be standby. This guy is called Shoaib. There will be 1,000 other Shoaib, there will be 1,000 other Rahul, there will be 1,000 other guys in the network, right? But for each and every client, there will be one mobility controller that will be elected, and for that, mobility controller will be maintaining these sessions, right? Now, the third advantage that you get from your clustering is seamless roaming. Wow, what is that? Let's talk about Shoaib. Now he is connected here. Now from here he's jumping here. From here he's jumping here. Let us assume this is the canteen location, this is the washroom, this is the data center, this is this, this is this. So he's not working at all. He's just jumping. He's moving, he's not doing anything. He's just roaming the campus. Right? Now, how is he able to stay connected to the network while roaming? And while he is on so many other applications, he's on YouTube, he's on Google, he's on Teams, he's on WhatsApp, he's doing many things. How is he able to do all of that while he is jumping from one access point to another access point? Because all the access points know for this client Shoaib, this mobility controller 2 is the user actor controller. So no matter where he jumps in the access point, all of them will be forwarding the traffic towards this mobility controller. And mobility controller is maintaining all the information for Shoaib, firewall session information. He may be on YouTube, he may be on Google, he may be watching some movies, he may be downloading some movies, he may be playing some games, he may be doing anything. All that information is maintained by your mobility controller, along with his IP address, the MAC address and everything, along with the authentication. Now, why is your mobility controller holding these keys? It is holding these keys because in Aruba, it's just not that Aruba is providing you seamless roaming, right? That is a beautiful thing. apart from that, Aruba is providing you seamless roaming in a secured fashion, right? So think about it. Whenever you are in your network, you have performed the .1s authentication, right? After performing the .1s authentication, you are moving from your canteen location to your washroom, from washroom to your desk, and you will be jumping from one access point to another access point. Do you think when you are jumping from one access point to another access point, do you give your username and password again? No, we never do that, because your controller is going to maintain that information. It is going to perform a quick TCP three-way handshake with this guy. What is that? This is the cache of the keys which is generated. This is the key which is generated for this guy Shoaib. How does your mobility controller know this is the guy Shoaib? This is the MAC address. It is going to quickly check whenever he's jumping from one access point to another access point. Access point is sending the traffic of Shoaib to the mobility controller. Mobility controller simply is going to check the MAC address, check the keys, if everything is matching, then it will allow Shoaib traffic to flow without any disruption. Right? So in Aruba, you get seamless roaming. That is true. But you get seamless roaming in a secured fashion. That is the beautiful thing about it. Right? So you get these three very critical advantages with your clustering. Right? So let's focus now. Let's see what is written here. So APs have APs have got these two tunnels like I told you. One is active AP anchor controller, one is standby AP anchor controller. Right? Users do not necessarily terminate on the same controller. Right? Meaning, so this is an access point, right? And this is a client called Shoaib. So there are four MCs. MC1, MC2, MC3, MC4. Right? For this access point, these two may be the active and standby, and this user is connected on this access point. However, for this user, this guy may be the active, this guy may be the standby. Right? It's not like that. Whatever controller that are active and standby for your access points, the same will be elected for your user. It's not like that. It is completely dynamic, and it is in control for your Aruba system. You don't have to do it. Right? Headless failover, we discussed all of that. Right? And when you're talking about your 7200 series, right, you can have up to 12 nodes in a cluster. If you've got 7000 series, you can have up to 4 nodes in a cluster. If you are using a combination of 7000 plus 7200, Aruba does not recommend that, but if you're still using it, you'll be limited to again. And the most important part is all the mobility controllers that are part of the cluster, they need to have the same operating system, same version. And if they do not have the same version, the AP failover will not come. Right? That was about cluster. Right? Next is your multi-zone. What is this, your multi-zone again? This clustering again, the most important part. This is an exclusive Aruba 8.x feature. You need to have a mobility master. Right? You need to have a mobility master for you to use all of these features in your cluster. Next, multi-zone, which is also a Aruba 8.x exclusive feature. Like I said, when I say exclusive feature, automatically this name should trigger in your head. MM, they need to have a mobility master. You need to have a mobility master. As simple as that. The third feature is multi-zone. Now, what is this multi-zone? Multi-zone is a feature, where it provides an access point with an advantage, where it will be able to terminate two different WLAN tunnels to two different mobility controllers that are part of two different administrative domains. Right? So typically, you want your corporate traffic to only enter your internal network. You want your guest traffic to be segregated to some other controller which is placed in the DMZ zone. If you have this kind of requirement, very specific requirement, then yes, you can do that, right, with the help of multi-zone. Let me tell you a little bit history about multi-zone, or why multi-zone was created. In the United States, many of the federal agencies, they do have wireless, Aruba wireless infrastructure, and most of the federal agencies. get the FBI, CIA, whatever that is. Most of the United States federal agencies do have multi-zone, do have Aruba as their infrastructure over their wireless infrastructure. Now, in that, there came a requirement where they had a requirement, they want to set up a guest WLAN and a corporate WLAN from the same access point on their existing infrastructure. They want to propagate the corporate SSIDs and the guest SSIDs as well. However, they do not want the guest traffic to enter the internet. So in these federal agencies, there may be certain VVIPs, VVVIPs, VIPs who will be coming to meet certain high-ranking officers in the federal agencies. Now, for these VVIPs, they need to have some kind of internet access, right? Now, for these users to provide guest access, federal agency gave a strong requirement to Aruba that we want this requirement. From the same access point, we want to propagate the corporate SSIDs, we want to propagate the guest SSIDs as well. However, we have a strict requirement that the guest traffic should not enter my internet. As simple as that. The guest traffic should not enter my internal network. You sell it somewhere else, I don't care. If you want me to buy something else, I'll buy. But the guest traffic should not enter my internal network, because in my internal network, I've got my resources, very sensitive resources, which is mining the data of most of the confidential information about the state of the country, whatever that is, right? And if the VVIP, VIP, if he or she has certain hacking capabilities, and if there is certain existing vulnerability in my network, which they are able to, hammer on. And typically, there is a vulnerability. They are able to hammer on it. They are able to retrieve some information about the data that is being stored in the federal agency. So they do not want it to have that scenario at all. That is why they said, we want to set up guest, but we do not want the guest traffic to enter the internal. In my internal network, only the corporate users, the officers who are going to need access to the internal resources. Right? Only for them, I need to provide corporate SSIDs. Their traffic will come using the internal network, right? Like this. However, the guest traffic, that should not enter my internet. Then what should I do? And Aruba came up with this multi-zone, right? With this multi-zone, it gives us it addresses that requirement, right? From the same access point, you are able to create two different WLAN tunnels, right? Two different WLAN tunnels, two different mobility controllers that are part of two different administrative domains, right? In multi-zone, we have got these two terminologies. One is primary zone, other is your data zone. However, this is multi-zone terminology. In our own understanding, this is nothing but our internal network. This is nothing but a DMZ zone. Right? So in the DMZ zone, you're going to set up a standalone mobility controller. Another standalone mobility controller, you'll be using the next generation firewall features to address your guest traffic. Guest traffic will not enter my internet. And this is just an overview, right? We'll be discussing more of that in your advanced courses, not in this course. Next is your dynamic segmentation. What is this dynamic segmentation? Now, when you talk about your Aruba mobility controllers feature, security feature, right? With the proper licenses in place, your Aruba mobility controller is capable of a next generation firewall, right? It has application analysis, it has deep packet inspection, it has RF, it has FCC, it has many other things as well, right? On the top of the head, I can see that these are the best of the best security features that your mobility controller possesses, right? Now, when you talk about your wireless network in Aruba, right? Aruba wireless network, all the wireless users will be connecting to the access points. Access point will be forwarding the traffic to the mobility controller. Mobility controller will be performing the authentication. After the successful authentication only, it will be enforcing certain roles, right? Some Shoaib is a guy, Shoaib is a guy who belongs to infra, right? So infra role will be enforced on this guy Shoaib. With this role infra, mobility control is controlling what the user can do and cannot do into the production net, right? So all of this, all the complete firewall policy applying to the user, then having control over the users, allowing or denying what they can do and cannot do into the production network, all of this is being sophisticatedly being handled by your mobility controller and its security features. But what about a wired network? What about your Aruba switch? What is the max thing that you can do? Right, you can set up a .1x authentication, you can set up a MAC authentication, you can set up a captive port authentication. But beyond that, you're not, the subsequent traffic after the authentication, you're not subjecting that traffic with the same kind of security features that you're providing for your wireless device. If you want to do that, if you want to impose the same kind of wireless security infrastructure for your wired infrastructure, then you can do that with the help of dynamic segmentation. Right? You can only use this on your Aruba switches, where what happens with Aruba switches is that we'll be configuring dynamic segmentation. With the dynamic segmentation, all the ports, all the users who will be connecting on the ports, their traffic will be just treated as a normal wireless client. Right? The traffic will go to the mobility controller. Mobility controller will be performing the authentication. After a successful authentication, right, it will be applying the roles, and with the roles, it will be controlling these wired users in the same fashion it manages your wireless. Right? The process, right, where you want to use the same kind of sophisticated wireless security infrastructure on your wired network, then that process is nothing but your dynamic, right? And you can only use this on your Aruba switches, not on third-party switches, right? Next is your control plane and data, right? It's two. You guys want to take a break, or you want to continue? We have got 22 more slides. You want to take a 10 minutes break in between? Guys. So next is your Aruba control plane and data plane, right? So we'll discuss the control plane data plane between your AP and MS. Now, like I told you, your mobility controller is a next generation firewall. So let's list out all those features. One is your next generation firewall features. Other is your application analysis. Other is your app RF. Other is your deep packet inspection. Other is your fix. Right, your mobility controller has got all these good security features with the proper licenses. Now, like I told you, there are two tunnels that gets established between your access point and your mobility controller. One is your PAPI tunnel. What is your PAPI? PAPI stands for process, or some could say protocol, application, programming, interface. Right, this is the control plane tunnel. Right, this is the control plane tunnel that gets established between your access point and your mobility controller. Now, what is going to happen in this control plane? Right, so whatever that we have configured for this access point, such as what is your WLANs, right? What is your AP name, right? What is your WLAN? What is your frequency bands? What are your channels, right? What are your channels? What is your WCA standard that you are using? along with that which flavor you are using, all these kind of what is your power level, right? All these configurations with respect to that access point will be pushed down using this control packet, right? Using this packet, right? Now, as this is a data, or I can say intellectual data. Now, you are a company X, other guy company Y, and other guy company Z. They have all bought the Aruba infrastructure and they are all using this. Now, whenever they are pushing any configuration from their controllers to their access point, that becomes their intellectual property, right? Whatever information that they are sending. IP name, WLAN, frequency band, channels, power levels, frequency band, WPS standards, everything. Right? Whatever that they're sending from their organization, that becomes their intellectual property. And this is the sensitive data. Right? Now, as this is sensitive data, Aruba has given us a free feature called CPSec, where once we enable CPSec, our PAPI tunnel will be IPsec encrypted. Right? It's just a configuration that you need to enable under your managed network. Once you enable that, your PAPI tunnel will be IPsec. Right? Now, AP will receive all these configurations from your mobility controller using the PAPI tunnel, all these configurations. Right? This is the name. Let us assume it is propagating a WLAN called employee. Right? Once it is propagating a WLAN called employee, your client should be interested to connect to it. Right? So once the user connects the client, connects to the access point, once it performs the authentication, right, the subsequent traffic coming from the client, this will be encrypted traffic. Right? So based on what you have configured, if you are using WPA2, WPA3, personal or enterprise layer, whatever that you have used, that will be used between client and your access point to perform the authentication. And after successful authentication, the subsequent traffic coming from your client, this will be encrypted traffic. And what is the type of traffic is this? 802.11. This is the wireless traffic. Now, what is your access point is going to do? As this is a wireless traffic and it is connected on your mobility controller on your wired media. Hello? Right? It is connected on an uplink interface on your mobility controller. And this is the wired media. It is trying to, your access point has to send this wireless traffic on a wired media. In order to encapsulate that, we are using GRT. Right? In the data plane traffic, your access point is going to simply push the client traffic. Why is it using GRE tunnel? To encapsulate your wireless traffic over your wired. That's your mobility. Once the mobility controller receives this information from your client, right? The mobility controller being the next generation firewall, first it is going to decapsulate the traffic.
Sure.
It has to first decapsulate the traffic because the traffic is encapsulated. This is the actual traffic. It is encapsulated. First it has to decapsulate the traffic, then it has to decrypt the traffic. Right? The wireless client, whatever traffic that he has sent XYZ, ABC, 1, 2, 3, something like this. And this he has encrypted. Right? It has to decrypt the traffic. Then check the firewall roles and policies. It is going to check who are you. This guy is sure. What do you want? I want to access this service. Okay. You want to access this service. Is it permitted? Which role are you assigned? You are assigned with the role infra. Okay. In infra, is it allowed to access this service? All of that will be checked by the firewall roles and policies that you have configured by your mobility controller. If it is allowed or permitted, then finally it will route or switch the traffic to its final destination.
Hello,
right? The mobility controller will finally route or switch the traffic to its final destination. Right? This is the complete control plane and data.
No, actually I'm on ACMA training.
And these are the GRE topics.
It's for 3
how
days.
many WLANs that you have created based on that. So for you So in this example, there are two W lines that are created. One is employee, other is guest.
Okay. No,
Both are
thank you, thank
created
you.
in
Maybe
different
you can
frequency
you can
bands. One is
record the class if it's
2.4
new. You can
and
can you
another is
please
5
record and
gigahertz
share it
frequency band.
later?
So for each W line,
Thank
for
you.
each frequency band,
Okay.
there will be one GRE tunnel, and along with that, there will be one extra GRE tunnel that is for your keep alive, to keep a track if your access point and the mobility control, if the peers are up or down. That is the purpose for your keep alive tunnel. Right? Now next is your campus API deployment model. That is a typical overview. Like this is your, on your right, you've got your mobility master, you've got your mobility controller that are part of a cluster, and you've got your different applications that you have integrated in your production network. And these have got your different buildings. Your access point is going to connect to your underlay layer 2 and layer 3 switches. The traffic will be forwarded to your mobility controller. Right? This is a typical remote AP and VIA deployment model. Right? So on your right, you've got your MM, you've got your MC, you've got your applications. Right? And in this DMZ zone, you need to have your mobility controller that are, which is a VPN concentrator. Right? And in your remote office, you've got your remote access point, which will be setting up the IPsec tunnel. You've got in your home, you've got your VIA client, who will be setting up the IPsec tunnel. Right? And all the traffic will be forwarded to the respective controllers and end. Right, next is your branch deployment model, very similar, right? So in your firewall, right? So on your right, you've got your MM, your MC, you've got your applications, and on your edge firewall, you've got your DMZ location. In that, you've got your mobility controller deployed in the VPN concentrator, right? And this controller will be setting up the IPsec tunnel from the edge router, from this edge router towards this MC deployed at the VPN concentrator, and that traffic will be managed by your mobility master. Okay, can you answer this question, please? Which of the following statements are true about the AP and controller communication?
Traffic data payments challenge.
Rakesh said all of the above. Okay, come please. Very good. Your guys have understood everything that I told you, except this is the tricky part. What is this tricky part? All traffic will be encrypted in IPsec when AP is deployed as a wrap. Is it true? You go back to that access points. Yes. Look at this. You've got a wrap here. Right, this is wrap. Now, in wrap, first is your IPsec tunnel. Again, IPsec tunnel is established. Inside your IPsec tunnel, you've got your PAPI and your GRE tunnel. Now, for your PAPI tunnel, if you are using CPsec, then your PAPI tunnel will be double IPsec encrypted. However, your GRE tunnel is not double IPsec encrypted. You have that option, you don't have to use it. Because whatever client which is sending to the remote access point, this traffic is encrypted. That is again being pushed into the IPsec tunnel, then being sent to the mobility tunnel. Right? So by default, in your remote access point, you have got these two tunnels, PAPI and GRE. They are enclosed in your IPsec. But your PAPI tunnel, if you are using CPsec as an option, then it will be double IPsec encrypted. However, your GRE tunnel is not double IPsec encrypted. You can do that. You have an option to double IPsec encrypted, but that is not needed. Right? That is not needed at all. Okay. Next is your license. Right? So next, first is your type of licenses. First is your evaluation license. Right? What is the evaluation license? Any software that you want to test it out in your production network. You have got a 90 days interval period. It has 3 30-day increments in which you can test it, and you can increase the evaluation time. But once it reaches the 90 days, right, your mobility controller is going to reboot, flush out all the configuration for which the licenses were not added. Right, so take the decision well before 90 days. Right, permanent license. Any software module that you have rigorously checked in your production network, you are satisfied with the performance of that feature, you want to buy the full license, go ahead and buy the permanent license. Next is the subscription-based license. Subscription license is typically a license where for certain features, you do not get permanent license. You get subscription-based license, meaning that you get 1 year, 3 year, 5 year, 7 year period licenses. You do not get permanent license, such as WebCC. Why is it like this? This is the strategic approach from the sales team to make money. That's it. Right? Next is your license type and usage. First is your MM. How do you calculate your MM license? You calculate your MM license by understanding the number of mobility controllers and the number of access points it is going to manage. Right? That is how you will be calculating your MM license. Let us assume you've got 300 access points and 30 mobility controllers that you are going to manage from your mobility master. Then how many MM licenses do you need? Number of mobility controllers, number of access points that you have. How many that we have? We've got 330 in total. Then we require 330 MM licenses. Right? How many components it is managing? That many licenses it needs. As simple as that. Right? So the components are the number of controllers plus the number of access points. Next is your AP license, right? Now, if you want your access point to propagate WLAN and you want them to operate as an access point, it requires an AP license, right? This is per AP, right? If you've got 300 access points, you need 300 AP licenses. PEF is where you want to make use of mobility controller security features, next generation of firewall features, application analysis, deep packet inspection. If I want to use all of those mobility control and next generation firewall features, then you require PEF license. Again, this is per AP license. If you've got 300 access points, using those 300 access points, you're connected to 3,000 users. It doesn't matter. But using these 300 access points, you're going to enforce the firewall features, then you require 300 PEF license. RF Protect license is typically used for your spectrum analyzer or air monitor, or if you're using multi-zone, or if you're also using dynamic segmentation, then you'll be requiring RF Protect license as well. Yes.
PEF only for instant AP or for all APs?
Which one?
PEF.
PEF is for all.
Or for all?
PEF is for all.
I thought it's only for instant AP. Is it something on
No.
Okay.
No. You need this license here as well.
Okay.
You need a license here as well. Yeah, MMC architecture as well. Right? So typically, Aruba has invested a lot of good money in setting up their MCS and next generation firewall. Apart from working as a typical wireless controller, it also has the capability of next generation firewall features. You can use it, right, on a very cheap price using the PEF licenses on all your production network, right? Next is your VR license. What is VR? VR is a VPN client software that you can install it on your laptops, phones, tablets to connect to your production network, right? And if you have got these users that are connecting to your production network, then you will be requiring VR licenses as well. And you calculate this per client, right? If you've got 1,000 clients that are using VR VPN client software, then you require 1,000 VR licenses, right? WebCC is again a subscription-based license, which is another license, which comes as an independent license where you want to use this feature for layer 7 capabilities, where you want to take permit or deny actions on certain URL category, web category, app category. You can do all of that in your mobility controller by having the WebCC license. Again, this is per AP. Right? If you have 300 access points, on 300 access points, you want to control 3,000 users on their layer 7 capabilities, you will be requiring 300 WebCC subscription-based license, right? Either in 1 year, 3 year, 5 year, 7 year. Finally, you've got advanced cryptography license, right? This is where you're not satisfied with the WPA2 or WPA3 encryption standards. there is a certain client in your production network who is working on a very confidential data, confidential applications. You are very worried about the encryption about that client data which is being sent into the production network. Then you can go ahead and buy an advanced cryptographic license, right, which uses suitable algorithm. It's like a cocktail of all the encryption standards, right? And this is per client. So there are 10 users who are very critical in your production network. They're working on very confidential applications or data which is very sensitive to the network. Then you can enforce advanced cryptography on that, on those 10 users, right? This is per client. Next is your centralized licensing, right? So this is a process where all the licenses by default will be held by a mobility master in a global license pool, right? All the licenses by default, it will be held by a mobility master in a global license pool. However, you can also create a dedicated pool, right, for a particular group. So in your production network, you may create certain groups based on certain cities. You may have a city called Hyderabad, or Bangalore, or Chennai, or Pune, or you may have in the same city or in the same physical campus, you may have got different buildings. And in different buildings, you want to allocate certain dedicated licenses. Then you can do that as well, right? And how do you do that? You need to go to your mobility master, configuration, mobility master system group, right? Mobility master system group configuration. And under that, you need to go to your license. Click on that, you get this page where you need to go to your license usage. Right click on this icon of your global license pool. You will see all the groups that you have created, right? So in your own production network, in your own physical campus, you may have got building 1, building 2, building 3, or you may have got your production network segregated in different cities, right? Here in this example, it's China, India, Portland. In your production network, you may have Hyderabad, Bangalore, Chennai, Mumbai, something like that. So like that, you can select one of the groups that you have created, and once you have selected, you get this enable local license pool. Click on it, and you will be able to add the license for different features in that particular group. Right? If you want to enable the license features, you need to go to your mobility master system group. Under the configuration, under the license, you need to go to your manual, license usage. In the previous section, you clicked on this. Don't click that, click on the text of the global license pool. As you click on it, you will see all the features that you want to enable, right? EP, PEF, RF protect, advanced